Hi students, welcome to the session on linear and non-linear systems. First we define what is linear system, right? So linear system, a system that obeys principle of superposition is known as linear system, right? So what is principle of superposition? A system which obeys principle of superposition is known as linear system. Now we have to define what is principle of superposition, right? So principle of superposition, it is that principle of superposition states that the response of a system to a the response to a weighted sum of input signals, right? The response of system to a weighted sum of input signals must be equal to the corresponding weighted sum of the outputs of the system. Weighted sum of the output of the system to each of the individual input signal, input signals, right? So what it is telling, you see that it is a beautiful concept, right? So the response of a system to weighted sum of input must be equal to the corresponding weighted sum of the output of the system to each of the individual inputs, right? So let us assume that we apply some input x1 to the system. Let us take this system. We apply some input x1 of t and it produces output y1 of t, right? Then we apply some other input x2 of t, it produces output y2 of t, right? Then the system is said to be linear if it obeys principle of superposition. What principle of superposition states that the response of a system to a weighted sum of the input, right? So let me increase the weight or scale the input. If I apply a times x1 of t, the output should also be increased by a times. That's what proper system or linear system. Similarly, if you scale your input by b times, the output must also be increased by the same factor. Yes or no? So what principle of superposition states the weighted sum. This is sum. What is sum? x1 of t plus x2 of t is the sum of input. But superposition states that the response of a system to weighted sum. Weighted sum means input 1 is weighted by a times, input 2 is weighted by b times. That's what the superposition states. The response of a system to the weighted sum of input. This is what my weighted sum of input. Let us call this is x3 of t must be equal to the corresponding weighted sum of output. What is the weighted sum of output? Then it should produce the output as weighted sum of individual output is a y1 of t plus b y2 of t. Weighted sum of individual output. This is one individual output, this is one individual output. Then if your system behaves like this is called linear system. See, let me express the same thing with one real-time example. Let us consider this is the bus. One boy is boarding the bus. Let us assume he has to take a 10 rupees ticket. So the output may be, the amount is a 10 rupee to travel from one point to another point, let us assume, right? This is what my x1 of t, this is what my y1 of t. Suppose if 5 boys boarded, that output is multiplied by the 5. So 50 will be the output that was received by the conductor. This is what A. This is what A Y1 of. One girl is boarding. Let us assume she has to pay 5 rupees. So 5. This is what my x2 of t. This is what my y2 of t. Suppose 5 girls boarded, 5x2 of t. This will become 5 into 5, 25. So what is the total amount the conductor has? It must be 50 plus 25, 75. Then only it is working properly. For 1 by 10 rupees, for 5 buys it is 20 rupees, means the system is poor system. It is not a proper system, right? If for one girl it is 5 rupees, means for 5 girls it is 25. Suppose if 5 boys and 5 girls boarded at the bus same time, he should have got 75 rupees, right? Then the system is said to be linear. If I give one input and get one output, if I give multiples of the same input, the output should be multiplied correspondingly. Similarly, for different input, the same thing should happen. If both the things occur at the same time, the output must be added. Weighted sum of output 50 plus 25. Individual output, weighted sum of individual output. That's what a linear system means. Are you understanding logic? Again, you can see in mathematics we know linear is proportional, right? We draw this line. You remember this? This is what linear curve we know. You see what is the thing? We know that it is this point maybe 1 comma 1, this point 2 comma 2, this point 3 comma 3. Then only we can call this a linear system 4 comma 4, right? Now you see, if I give input, this is x is input, y is output. What it is telling? If I give x is 1, the output is 1. If I give x is 2, 2 means what? 2 times. The output will also be 2. Output is scaled by the same factor. Yes or no? Now the 2 becomes a, here output is also scaled. You see that? Now, if I give another input, x is 3 or x is 3, the output is again 3. If I scale it by some other factor b, that is by 2, so 2 into 3, 6 means the output will also be 6. Yes or no? That's what a linear system. Again you see, if I give 1, the output is 1. If I give 2, the output is 2. If I add the input and give like this, that is 1 plus 2, 3, the output is also added. That's what a linear system. You see, the input is added 1 plus 2. Similarly, the output 1 plus 2 is added, so it will give 3. Similarly, the output is also added, so if you give 1 plus 2, the output will be 3. So this curve satisfies a linear. So the thing is, in mathematics, this is also linear, proportional, this is also linear, but here we have to bother whether it is passing through origin. That is very, very important. That and all I have told in the, I have kept one video that I will post for problem solving. At that time you will understand. So the curve should be passing through this. That means when x is equal to 0, the output must be 0. Here you see, here the input is 4, the output is 0. This is not linear for us. So here you see the input is, for example, minus 4, the output is 0. This is not coming under the category of linear. So this must be very, very important. It is mathematically it is linear for our system. For 0 input, the output must be 0. Then only system is proper, right? So this must be taken care. That I will explain in the problem solving session, right? So that's all about linearity and non-linearity. Thank you.